Applying for a loan adds an obligation for the one applying for it. It is the obligation to regularly pay the amount both parties, the lender and the borrower, agreed. Loans are repaid with regular payments on a regular interval of time. It is called the amortization method. Amor- Amortization method is where paying a loan, principal and interest, are done through installment basis, usually of equal amounts at regular intervals. It can be paid monthly, quarterly, semi-annually, or annually for a certain period. So recall that when the payment period is in the regular period is in monthly, we use 12 for the M, and quarterly we have 4, semi-annually 2, and annually 1. So the period here are usually years, and the regular uh, regular payment intervals are can be monthly, quarterly, semi-annually, or annually. So in case the loan is not paid fully, the borrower has an outstanding balance. So we have outstanding balance. Just in case if the borrower doesn't pay or cannot pay the regular loan on time, or it is the any remaining debt at the specific time. One method to compute the outstanding balance is to get the present value of all remaining payments. So this method is called the prospective method. So when we use the the present value to solve for the outstanding balance, this method is called the prospective method. To illustrate what I have just talked about, here is an example. So Mrs. Lazaro got a loan worth 800,000 pesos. She promised to pay the loan every 6 months in 5 years. The semi-annual payment is 103,603.66 if the money is worth 10% compounded semi-annually. The question is, how much is the outstanding balance? So we write the given values first, and we have the loan worth 800,000 pesos. So we have 800,000. She promised to pay the loan every 6 months in 5 years. So with this we have it's because it's every 6 months, we know that the regular payment is semi-annual. So we have M equals to 2. And the period is in years, which is 5 years. So we have our N equals the number of payment is equal to MT 2 times 5. We have 10. Then the semi-annual payment is 103,603.66 pesos. This is what she's planning to pay every 6 months in 5 years. So this is our regular payment in semi-annual, which stands for R for regular. We have 103,603.66. So I have to add a sentence here. I think I forgot, just slipped my mind. We have how much is the outstanding balance after the third term. So that's the full question. How much is the outstanding balance after the third term? So we write the third term as our K. Okay, we have K equals 3, which means that how much is the outstanding balance after the third term, or the third year in 5 years of payment. So we write the formula for the outstanding balance formula mm, B sub K equal to R times 1 minus 1 plus J to the power of negative n minus K all over J. So note that our interest rate for the semi-annual is 10%, which is 0.10. So we have B, and third term we have 103,603.66 times 1 minus 1 plus 0.10 divided by M. If you remember, J is equal to I M of M. So this is 2 to the power of negative Rn is 10 minus the third term K all over J, which is 0.05. So solve this in your calculator. We will have 103,603.66 times 5.79, which is equal to 599,480 9 point something. Let's just say 62. Another, we have Mr. Moran is paying 81,372.02 pesos yearly for a loan worth 500,000 pesos. If the interest rate is 10% and the loan is payable by 10 years, how much is the outstanding balance after sixth payment? So as usual, we write the given values first. So we have the regular payment yearly, which is R is 81,372. For a loan that is 500,000, if the interest rate, annual interest rate is I to the 1, which is 10%, which is 0.10, and the period for payment is 10 years. Our N would be MT, which is, since it's annual, we have 1, and our years is 10. We have 10. Then we have our K, which is the sixth payment. Oh my god. So we have the formula for the outstanding balance. So I'm just going to plug it all in. We have B sub 6. We have R as R 81,372 times 1 minus 1 plus 0.10, 1 is negative 10 minus 6. We have 0.10. Let your calculator do the work. We have 81,372.02 times 3.17. Then we have an outstanding balance of 257,940.51. That's it.